Good morning, everyone. I'm Ronald Hilbilang. I'm a science research specialist for Project GUHeat. So today I'm going to present to you a study that I made. So today I'm going to share to you a study on the use of mesoscale model in WRF to map urban heat islands of regional area. So since I am the last presenter for this topic, let me recap to you the discussion that was made by the previous speakers. The first speaker discussed to us about the objectives and what project it is all about, while the second speaker discussed to us the urban heat intensity or island in the Philippine context. He discussed about some of the main causes, which includes the loss of vegetation and built-up expansion. On the other hand, the third speaker discussed to us about the creation of an index to explain built-up structure, and he also determined what are the impacts of these factors or indices when it comes to LST. While lastly, the fourth speaker discussed to us about the use of high resolution or generating resolution land surface temperature map using machine learning algorithms. Now, in this topic that I'm going to discuss to you, this is a different approach or may ibang approach tayo dito because yung dalawang speakers natin previously, ang discussion nila is all about land surface temperature. But in this topic that I'm going to discuss, it's more on air temperature naman. Now, the question is, bakit hindi sapat or why won't we just use LST or land surface temperature? Well, most of us, especially what we feel in terms of hotness ba or coldness is at hindi siya sa land surface naka-base but rather sa minsan at a certain height or a certain level, usually at 2 meters. So this is where the model comes in, or the mesoscale model comes in, because it also models air temperature. Now, this is an overview of my presentation. So just a brief overview of urban meteorology. Meteorology is a vast topic or subject, but we're just focusing on urban. And then we will talk about different atmospheric models and how do we urbanize these atmospheric models to include urban features. Then we will be discussing WRF in particular and what are its features in terms of urban urbanizations. A case study Canopy model. All right. And so for most of us, meteorology is not actually a new topic or hindi siya bago sa atin because we encounter it every day, especially pag nanonood tayo ng news, diba? One of the things that we usually look forward to is, ano ba yung forecast ng weather for tomorrow? Is it raining? Or will it rain? Or will it be sunny? Or gaano siya kainit? Now, for some of us who have been following Project GUHeat, we have been releasing some IECs related to heat index, real-time heat index for the past two months. In particular, let me just zoom in on the specific topic of urban meteorology. It starts actually with the phenomena called urbanization in people or influx of people going usually in one area due to several reasons, spreading economics, or as these people in an area, the natural landscape of that given area is being altered or being redeveloped to give way to the needs of the people. So sometimes kaya mapansin natin na there is an immediate rise of infrastructure such as residential or commercial or industrial. It depends actually on the need. Now, because of these structures na nag-build up natin, it tends to disrupt or change the natural landscape. And with that change in natural landscape also comes an effect. Now, with the natural landscape and also the alteration or the reconfiguration of the natural landscape, both of this gives rise to a unique system, what we call the urban ecosystem. Now, the urban ecosystem is composed of, or is built, is composed or comprises of different spheres, such as urban atmosphere, biosphere, hydrosphere, and the built system. All of this together comprises our ecosystem. Now, partly, the third speaker, Mr. Jim, discuss some of the indices or indices that we can use for biosphere and for the built-up system. Now, with this urban ecosystem, this is actually unique per city kasi iba-iba yung features ng iba-ibang features per city. So with these unique features, it also comes with its own local weather event or climate. Now, again, it's local and it's unique. Climate for Metro Manila does not necessarily reflect of that in Cebu or in Davao since it's unique. Now, at the end of the day, because of this local weather and climate, it affects our daily human activities, such as yung biglang init, mataas yung heat index, it affects our health and so much more. Energy consumption and other else. Now, here are some of the urban features that I mentioned a while ago that alters urban weather or climate. Example, release of pollutants from aerosols sa industrial. We have street geometry, building distributions, gaano karaming building for a certain area. And also is of importance is anthropogenic heat. This is the heats given off due to human activities such as transportation, exhaust from diesel engines, and we also have heating and cooling systems from different buildings. Then another one is yung impervious materials such as artificial structure, especially yung ginagamit natin sa roads natin. Is it asphalt or what kind of material that is? That has bearing in terms of urban weather. And lastly, a building morphology, building size or the shape or how it is, the shape and the number of stories of the building. Now, given all of this, given these features that I've mentioned, how does these features actually affect our local climate? Now, I'm showing to you a figure here of two scales, which is a mesoscale and also a microscale. Now, mesoscale is a larger encompasses a larger extent. Usually, it's from a few kilometers to several kilometers, pwedeng umabot ng 100 kilometers. Well, on the other hand, microscale, it's less than 1 kilometer usually ang extent ng area. Now, let's try to look at this and let's try to correlate the features that I've shown a while ago and how does it affect urban atmosphere. Example, in this case, in a mesoscale level, diba, wind flows naturally, depends on the direction where it goes. But then, because of urban features such as buildings na matataas, wind is impeded. The flow of wind is impeded. And then, because of these building structures, there is what we call an increase in roughness length. Now, the decrease in wind slows down wind, and it has an effect in terms of air temperature because of its dispersion. Now, another one is yung addition of heat from roofs, sa urban canyon, and then the anthropogenic heat release sa mga AC systems natin or cooling systems. Now, let's try to look at the microscale level naman. So, here we have the concept of urban canopy layer. This is the layer na hanggang sa rooftops, building ben or bahay. Now, here are some of the how these urban features affect the urban atmosphere. Example, absorption of solar radiation dahil doon sa material na ginamit natin because it has low reflectance. And then we have limited sky view. Our cars here contributes to heat as well. And then we have our roads, impermeable surfaces. And then depende rin sa the geometry of our building, it causes sometimes trap warm air and slow turbulent winds. Now, after discussing what are the effects of this urban features, how does it affect in our daily lives? So here are some of the examples. Number one, it causes urban heat island effects. So usually, urban heat islands is more prominent during nighttime. Instead na malamig yung gabi natin, mainit pa rin. Next is urban flooding. Nakikita na natin to sa Metro Manila, which is predominantly during the rainy season. There is a change in precipitation pattern, may increase ng gaseous pollutants and aerosols, and may correlation din siya sa pag-increase din ng temperature natin and the street canyon winds. Now, we discussed what are its effects in terms of sa people. Now, how do we address this? How do we answer this? Now, it's very important that we get to characterize this first. We need to understand how it happens, bakit nangyayari siya, before we can come up with a solution or mitigating strategies. Now the question is, how do we characterize it, or how do we visualize it or understand it? We use the tool that we usually use is through modeling. Now in modeling, we take into consideration real-world phenomena and we try to simulate it to better understand what is happening. So one of this atmospheric model that we can use is the numerical weather prediction model, or NWP. So here are some of the things it does. First is it simulates real-world phenomena. Next, it parameterizes. Now, very important in this sense of simulation, because it tries. It does not necessarily or 100% capture the phenomena, but it tries to accurately simulate. And to do that, we have to parameterize some physical processes. And then, after we do that, we solve a set of equation for us to generate this prediction. And then for urbanization, or for atmospheric models with urban features, we try to integrate urban atmosphere condition. So this is an example of the NWP output. This is for Caraga region. So this is the parameterization we take into consideration in the model. We parameterize solar radiation. Nire-represent natin siya. Topography, nire-represent natin siya dun sa model and evaporation such. So one of the models or tool that we use is what we call the weather research forecasting model, or WRF, the weather research and forecasting model. So WRF is an open source mesoscale NWP system, meaning it can be used by everyone. Since this is open source, you can just register with NCAR and then download it. And it is used for atmospheric research and operational forecasting applications. Pag-asa uses one WRF as well, among others, to do the forecasting. And some of you might be, it might be of interest to you kung ano yung applications ng WRF. Parang air chemistry, something to do with air quality, hydrology, fire weather, so on, solar wind energy, and LES modeling. Now, of key importance here in WRF, why it is better, why it's better compared to other models, is that it integrates urban canopy options for us to be able to simulate urban features or urban scenarios, weather scenarios. This is just an overview of WRF. What this figure is actually telling us, we need to input some initial conditions, and then this generates the initial and boundary conditions, and then WRF solves the initial and boundary conditions, and then it generates this figure. And then we can do further analysis on it. Temperature man yan siya, or LST, or wind. So this is the urban canopy model that is integrated in WRF. So we have different options: SLUCM, single layer, building effect parameterization, and building energy model. Now of notice here is the BEP and BEM, because BEP and BEM takes into consideration different parameterizations. Di ba nakita natin kanina sa urban features, we have buildings, sizes, radiation, sun radiation. So lahat po yan siya kino-consider ni BEM, and also some anthropogenic heat sources and mga air conditioning systems. This is an example of using WRF to simulate urban weather. For example, in this case, this is potential air temperature using SLUCM, or the building energy parameterization. Now, we can also use WRF to simulate different scenario for mitigating approaches. What if we increase albedo, or yung reflectance ng surface natin, something to do with the materials that we use? What if kung yung density ng buildings natin, area natin is sparse? Or what if we put a central park in the middle? Will it affect, or will it have any effect in terms of urban heat? Or kung hindi central park, what if we distribute natin ang parks natin? Will that also have an effect? So we can do that here in WRF. So this is an example of the 2-meter air temperature for different cities from some mga previous engagements namin with Caragas, RSTW, in Davao, and also in Zamboanga during the Regional Science Technology Week. Now we come to the part wherein the last part wherein we discuss the case study, or the case study for my study. So the title is The Simulation of Urban Heat Island during High Heat Event using WRF Urban Canopy Models and a case study for Metro Manila. Now, the study period is from April 22 to 30 because accordingly it has one of the highest heat index for that month in April. And alam naman natin na usually March, April, May talagang mainit na time for the Philippines. Now, this land cover here, originally, sa WRF kasi, this is only just urban area. It is only categorized as one. But it's very important that we get to subcategorize it depending on the density of the number of buildings, the density of, for given area. So, for us to do subcategorization of our urban area, we use the VIIRS nighttime image, and then we use an index, the Human Settlement Index, for us to do this subclassification. Now, I'm going to share to you some major findings from the study in terms of air temperature, the relative UHI intensity and heat index. So this is the NCR 2-meter temperature map at 8 a.m., at 2 p.m., and also at 8 p.m. Some major findings na lang po. There might be some methodologies that I might be skipping. If you are interested to find out, a separate study will be released soon. So for example, some major findings, there is an inverse relationship between wind speed and temperature. The lower the wind speed in a certain area, mas mainit yung lugar. So for example, in this case, in Northwest Metro Manila, medyo may pagka-stagnant yung wind natin. And as we can see from the gradient, mas mainit yung lugar na ito, Northwest Manila. Now, what is the reason for the stagnant air? So accordingly in a study, because of increased roughness length, dahil nga sa dami ng buildings, it reduces wind speed. And as a result, because of the reduced wind speed, nagkakaroon tayo ng increase na temperature, air temperature. Now, this is air temperature 2 meters. Now, on the other hand, where strong winds are, the areas near it tends to have a lower air temperature, as we can see here in Laguna. So, compare dito na mainit, at saka compare dito na may malalakas na wind speed, mas malalamig yung area na to relatively to this area. As you can see, as it also evolves from 8 a.m., 2 p.m., and also at 8 p.m. also in the evening. So at 8 p.m. in the evening, mainit pa rin ang Northwest Metro Manila. And that is indicative of the urban heat island. Now, next is the presence of the presence of POW and wind effect. Usually, this is a result of higher air temperature sa areas na leeward or the leeward side or sa baba ng mountain ranges. For example, this is the Sierra Madre mountain range. As you can see, mainit yung area din na ito even if it has mataas na wind speed. So further discussion of this effect can be seen on the paper that will be released soon. So temperature by cities. For the entire study period from April 22 to 30, so the highest is Navotas City, both daytime and nighttime, while the lowest is doon mismo malapit sa Laguna Lake. For Muntinlupa City, it's 30 and 47.47. Now another one is the relative urban heat intensity. Now what this map shows you is the hot spot and cold spots in terms of air temperature. The negative values here are the cold spots and the positive values are the hot spots. Now, since this is relative, we have a reference point. So the reference point here is that, kasi when we talk about urban heat intensity, this is the difference of the temperature in an urban area or rural area minus the temperature in a rural area. So ang reference point natin is na GUHeat because mas mataas yung hourly or temporal resolution niya. 47 kilometers from Metro Manila and is considered an agricultural area. So again, negative is cold spot and positive values are hot spots. Now, the maximum UHI recorded is recorded at nighttime, which means na mas mataas ng 3 degrees yung temperature ng NCR compared doon sa Cavite, sa Night Cavite. Again, an indicative. This is indicative of the urban heat island effect. So as you can see, consistent hotspots are observed northwest of Metro Manila, and as it evolves through time, nagsistay the same pa rin siya. But on the other hand, this is a unique thing, kasi for the areas in Laguna Lake, pag morning and nighttime, medyo hotspot yung kanyang characteristic. But in the afternoon, nagko-cold spot siya. And lastly, this is the average heat map index. Usually when Pag-asa gives release yung heat index natin, it's a point based. For example, sinabi nila it's 41, so it's based on Quezon City or Science Garden sa Quezon City. And it may not necessarily reflect of that pagdating sa, let's say, in Muntinlupa or in Las Piñas. So this is an average heat map index. So what this actually tells us is that at 8 a.m., 8 pa lang ng umaga, mataas na kagad yung heat index natin sa area ng Manila, Pasay, Makati, and Mandaluyong or the central parts. This one. And then by 2 p.m., nag-evolve yung ating temperature high heat index and it covers almost the entire Metro Manila. And then at nighttime, this is of interest kasi at nighttime, meron pa rin tayong mataas na heat index. Now, this is very important, especially for those people na walang air conditioning systems because it has an effect sa health nila, especially for the vulnerable, children or the elderly. Another thing to notice here is that yung mga bodies of water tend to have a high heat index because of high humidity. And as it moves away from the bodies of water, may decrease tayo ng 1 to 3 degrees Celsius na heat index. And as I mentioned a while ago, thermal discomfort is observed throughout the study period, even at daytime or nighttime, and it poses concerns, especially in health for the children and the elderly who are vulnerable. Now, the heat index classification, the highest for the study is in Navotas City at 35, and then the lowest heat index is in Marikina at 31. Now, in conclusion, because of the urbanization that's happening, the trend for urbanization will continuously happen. Okay? Because of this continuous influx, there is a reconfiguration of land areas or the land cover. And dadagdagan pa natin ng anthropogenic contribution for cars, AC system, it creates a local climate, a unique local climate. Now, this has an effect in our daily lives. That's why it's very important for us to model this so that we can better understand how it affects and how can we make a mitigation strategy. One of the models that we can use is a mesoscale or WRF, which is a model we can use as a decision tool for creating policies or projects in mitigating urban heat island effect. So if you have any further questions regarding the study, you may reach us sa website or through the email that we have. So thank you for listening and keep safe.